Start.
So,
Yeah. Yeah, say. Okay.
fuels and lubricants. Sa fuels, may classifications. There are three general types of fuel: solid, liquid, and gaseous. So, sa solid, yan, including coke, that, coal, peat, briquettes, wood, charcoal, and waste products. Then sa liquid, including petroleum and its derivatives, synthetic liquid fuels manufactured from natural gas and coal, shale oil, byproducts, including tars and light oil, and alcohols. Sa gaseous naman, including natural gas, manufactured and industrial byproduct gases, and the propane and butane or liquefied petroleum gases that are stored and delivered as liquids under pressure but used in gaseous form. Ayan siya. So, sa section 2.0, yun yung solid fuels. 2.1, coal classification. Yan. Three methods of classifying coals have been adopted as standard in the United States. These classifications are by rank, by grade, and by type or variety, determined by the nature of the original plant material and subsequent alteration thereof. Other methods of coal classification are by use or suitability for specific purposes or types of combustion equipment, and by various trade systems set up to meet conditions in each area or time. So, classification by rank. Probably the most universally applicable method of classification is by rank, in which coals are arranged according to fixed carbon content and calorific value in BTU calculated on the mineral matter free basis. So yan, makikita natin sa graph yung yan, classification by rank. Yun, pinakamababa yung lignite, sunod yung bituminous, tapos medium rank coal naman bituminous, high rank coal yung anthracitic. So, classification by grade. The standard for classification of coal by grade provides a symbol designation system indicating size, BTU content, ash softening temperature, and sulfur content of coals. So, sa steam coal, wait lang. Steam coal is a grade of coal used in electric power plants to generate steam to create electricity. Most of the coals mined in the United States are steam coals. Steam coals for power plants must meet quality and heating characteristics of the boiler design and for design of pollution control equipment at the power plant. So, next yung metallurgical coal. Some coals can be used to produce coke, an important raw material used in steel making. These coals are referred to as metallurgical coal, met coal, or coking coal. These can be considered grade terms. Then yung chemical and specialty coal. Certain coals can be used to produce chemicals and specialty products. This is a small percentage of the overall coal market. Chemical and specialty coals must meet very specific requirements for the product or chemical process in which they will be used. So requirements may be related to ash and sulfur contents, as with steam coals and metallurgical grade coals, but also may be related to mechanical properties or to chemical composition. Yan. Then, nalaglag yun. 2.4, yung burners for pulverized coal. Shows schematically the basic methods of feeding pulverized coal and air to furnaces. 2.5, furnace heat release and heat available. Furnaces are pulverized coal firing are designed either to remove the ash as molten slag intermittently or continuously as dry ash. Wet bottom construction generally is chosen for low-grade coals that have low fusion characteristics, whereas dry bottom construction often is selected for high fusion coals. Section 3 is yung coke. Ayan yung itsura ng coke. So, coke is the solid infusible cellular residue left after fusible bituminous coals are heated. In the absence of air, above temperatures at which active thermal decomposition of the coal occurs. High temperature coke is made from coal at temperature ranging from 815 degrees C to 1093 degrees C. Low temperature coke is formed at temperatures below 704 degrees Celsius and the residue, if made from a non-cooking coal, is known as char. Section 4 is wood and hog fuel. Wood fuel may come to the boiler plant in the form of cordwood, slabs, edging, bark, sawdust, or shaving, and frequently several forms of available together. A. Properties of woods. The major variable in wood is moisture content. Air-dried wood seldom contains less than 12% water, whereas kiln-dried usually contains from 1 to 7%. B. Combustion of wood and wood waste. Require intelligent handling, knowledge of their composition and the importance influence of moisture, and understanding of the three-stage wood combustion process. These three stages of combustion involve evaporation of moisture, distillation and burning of volatile matter, and three, burning of fixed carbon, example, the residual charcoal. There are three general methods of burning wood fuels. True combinations may be used. Wood fuels may be turned in moving bed on an inclined grate, in suspension as in spreader strokes, or in piles in flat grates. Method 3 is the slowest. Method 1 tends to segregate the three combustion stages. It is necessary to supply excess air in burning wood fuels. Section 5, Miscellaneous Solid Fuels, 5.1. Charcoal provided the only carbon for steel making and other metal smelting from prehistoric times up to the 18th century in Europe and up to early in the 19th century in the United States, when coke gradually began to take place of charcoal in steel making. A. Production. Charcoal is produced by partial combustion of wood at about 400 degrees centigrade and with limited air. It may be made in kilns, ovens, buried pits, and or any suitable type of enclosure in which wood can be piled and burning can be restricted through control of inlet air. Byproducts. Both hardwoods and softwoods are now used in the production of charcoal. Hardwood charcoal weighs about 31 kilograms per cubic meter and softwood charcoal about 28 kilograms per cubic meter. When very resinous wood are processed in sloped clay floor kilns, tar is formed from the resin in the wood. Charcoal is seldom sold on specification. The usual market guarantees relate only to weight per cubic meter and to volatile and moisture content. The maximum of 14% volatile and 2% moisture is customarily established. The heating value of charcoal ranges from 25,531 to 32,495 kilojoules per kilogram and can be approximately calculated from Dulong's formula. So ito yung Dulong's formula. Yung higher calorific value is equals to 1 over 100 multiplied by 8,080 C, which is yung percent carbon, plus 34,500 H, which is hydrogen, minus 0 over O over 8. So yung O is yung percent oxygen, plus 2,240 S. So yun yung sulfur. 5.2. Straw, paper, and miscellaneous waste fuels. With properly designed equipment, almost any solid material having a heating value exceeding that required to evaporate the moisture in the material can be used to produce heat and power. The important consideration is that an adequate and assured supply of the material be available at a price, including transportation and handling, to make the installation economically sound. Section 6, liquid fuels. So 6.1 is characteristic of fuel oil. Letter A. Fuel oil is defined as any liquid or liquefiable petroleum products burned for the generation. Yeah, hindi ma-off, sir, eh. Paano yun, sir? Okay na po, sir? Pag ganyan. Hello, hello. Okay na po. So, Section 6, Section 6, liquid fuels. 6.1, characteristic of fuel oil. Letter A. Fuel oil is defined as any liquid or liquefiable petroleum products burned for the generation of heat in a furnace or firebox. Of the generation of power in an engine, exclusive of oils with a flash point below 37.7 degrees centigrade by the tag closed tester, and oils burned in cotton or wool wick burners. 6.2. Commercial fuel oil specifications. So letter A is flash point. Flash point is the temperature to which oil must be heated to give off sufficient vapor to form an inflammable mixture with air. It varies with apparatus and procedure, and both must be specified when flash point is stated. Excuse. The minimum flash point usually is controlled by law. So ito yung ginagamit sa para makuha yung flash point. Nakalimutan ko lang yung tawag. So letter B, pour point. Pour point is the lowest temperature at which oil will flow under prescribed conditions. So yan, makikita natin, oil without pour point, the presence, then yung meron, yan yung pinagkaiba niya. Letter C, carbon residue. The carbon residue test in connection with other tests and the use of for which the oil is intended furnishes information and throws light on the relative carbon forming qualities of an oil. So ito yung yung ginagamit para sa carbon residue test. Then letter D, ash. The ash test determines the amount of non-combustible impurities which come principally from the natural salts present in the crude oil, from chemicals used in refinery operations, or from seawater contamination, as in the case residual fuels transported by sea. They also may come from scale and dirt picked up from containers and pipes. Letter E, the viscosity. Viscosity is a measure of the resistance of oil to flow. It is the time in seconds in which a definite volume of oil will pass through a tube of specified dimensions at a definite temperature. 6.3. Fire brick and refractory cement. Fire brick and refractory cements should be selected on the basis of the service in which they are used. A grade higher than absolutely necessary should be chosen because of abuse under extreme operating conditions. The life is refractory material in combustion chambers is shortened by sustained high temperature, by rapid changes in temperature, and by panting or vibration from combustion. Next is 6.4, furnace floors. The burner's manufacturer usually specifies the furnace floor construction. The several layers are as follows. Number 1 is insulating brick or material. Number 2, first course of brick dry laid 1.6 millimeter apart to provide for expansion joints broken between adjacent rows. Number 3 is dry refractory cement, filling all cracks and covering bricks to depth of 3.17 millimeters. Number 4 is second course of brick similar to first, overlapping joints in first course. And 5, day refractory cement as in number 3. After firing the bricks take a permanent set and the cement vitrifies to a hard surface. For airports built into the floor, the bricks may be set in refractory cement mortar. 6.5. Metal combustion chambers. Yan yung itsura ng metal combustion chamber. For wet-based domestic heating boilers and forced warm air furnaces, stainless steel combustion chambers are used extensively. Type 40, 430 stainless steel, 17% chromium, is representative of the lowest grade material that may be used for this service. Section 7. Storage and handling of fuel oil. Fuel oil storage tanks generally are classified by material as steel or concrete, by size as gallons, etc., by location as exposed or inside, underground or buried, and by use as light or heavy oil tanks. The essential requirements for tanks are tightness and durability. Section 8. Gasoline and kerosene. 8.1. Gasoline is defined as a refined petroleum naphtha which by its composition is suitable for use as a carburant in internal combustion engines. The term is often applied to hydrocarbon liquids used as solvents for specific purposes, such as cleaning, manufacture of rubber, cement, of manufacture of paints or varnishes. Letter A. Motor gasoline for automotive use is mixture of hydrocarbons distilling in the range of 37.7 degrees centigrade to 204.4 degrees centigrade with a standard method of test. The elementary composition of gasoline by weight is, in general, not far from 85% carbon and 15% hydrogen. The air-fuel ratio for stoichiometric requirements in the combustion of gasoline and kerosene varies between 14 and 15 kilograms of air per kilogram of fuel. 8.2. Explosive mixture of gasoline. Mixtures of air and gasoline vapor containing from 1.3 to 6.0% of gasoline vapor by volume are explosive. 8.3 is kerosene. Kerosene is defined as a petroleum distillate having a flash point not below 22.8 degrees centigrade as determined by the Abel tester, which is approximately equivalent to 22.8 degrees centigrade as determined by the tag closed tester, and suitable as an illuminant when burned in a wick lamp. 8.4 specific volume of gasoline and kerosene completely vaporized at 1 atmospheric pressure and at 15.6 degrees centigrade. 8.5 is alcohol. The alcohol most frequently considered as fuel for internal combustion engines is ethyl alcohol, sometimes called grain alcohol. Its modern chemical name is ethanol. Two other alcohols that have been used as fuel are methanol and isopropanol, which are also called methyl alcohol and isopropyl alcohol respectively. 8.6. Coal tar and tar oil. Coal tar is a product of the destructive distillation of bituminous coal carried out at high temperature. A typical composition of tar is C, 86.7%, H, hydrogen, 6.6%, N, 0.1%, S, sulfur, 0.8%, O, oxygen, 3.1%, ash, 0.1%, water, 3.2%. The black color is due to the free carbon in suspension, about 4%. The high heating value equals 37,925 kilojoules per kilogram. 8.7. Liquefied petroleum gases or LPG are mixtures of hydrocarbons liquefied under pressure for efficient transportation, storage, and use. They are generally composed of ethylene, propane, propylene, butane, isobutene, and butylenes. Commercially, they are classed as propane, propane-butane mixtures, and butane. They are odorless, colorless, and non-toxic. Section 9. Diesel fuel oils. Diesel engines in general are capable of burning a rather wide variety of liquid fuels. The large cylinders, lower speed diesels will burn a wider range than the smaller engines, while vegetable and animal oils have been used to a limited extent. The most available and cheapest liquid fuels are mineral oils, usually derivatives of crude petroleum. Classification. Refiners grade fuels broadly according to methods of production. Number one, distillate fuels are produced by distillation of crudes. Various grades are distinguished according to choice of initial and final boiling points used in the process. Number two, residual fuels are those left after the distillation process. Number three, blended fuels are mixtures of straight distillate fuels with cracked fuel stocks. Cracked stocks are residual of fuels which have been treated thermally or catalytically to obtain yields of lighter grade fuels or gasoline. Specifications. Terms usually employed in diesel fuel specifications are specific gravity. Seldom used, compares the weight of the fuel with water. It is expressed as a decimal with water taken as 1. The term API or American Petroleum Institute gravity is frequently used. Water is taken as API 10 degree. Oils lighter than water have higher degree API gravity. So, yung plus point, yung sabi ko na kanina. Is the temperature at which a fuel gives off vapors ignited by an open flame and is significantly only from handling and storage standpoints. The strong pour point is important only for handling and storage reasons. Heating coils in storage tanks may make possible the use of high point fuels in cold weather. Then, viscosity. Viscosity is the measure of resistance to flow, important from the standpoint of handling through piping, especially in cold weather, and very important for injection characteristics. Volatility and distillation range. Volatility measures vaporizing tendencies and is usually expressed in distillation range temperatures. Cleanliness, contamination such as water, abrasives, gummy constituents, pipe or tank scale, or sludge must be eliminated. Ash content includes non-combustible mineral materials. Abrasive in action in engine cylinders must be limited to less than 0.01% in slower speed engines. Corrosion. Fuel should be non-corrosive by test, but this may not correlate with corrosion of fuel system parts. Sulfur may be present in many forms, some corrosive and some non-corrosive. Products of combustion of sulfur-containing fuels are likely to be corrosive or cause deposits in engines. Carbon residue is sometimes called Conradson carbon. It is the carbonaceous residue remaining after destructive distillation, expressed in percentage by weight of the original sample. Ignition quality. In smaller engines, is one of the most important characteristics of a fuel. The term is used to express the speed at which combustion starts and continues under service conditions. Cetane number. The usual method of expressing ignition quality is the determination of delay angle of the fuel in a standardized test engine. The delay angle is the angle of crankshaft revolution between the beginning of fuel injection and the first appreciable rise in pressure due to combustion. Fuels with high cetane numbers give smooth combustion and provide easy starting. The slower the engine speed, the less the importance of the cetane number. 9.3, the fuel selection. So, wide and numerous variations in engine design, such as of cylinder, speed of revolution, form of combustion chamber, and injection system, affect fuel requirements. In selecting fuel oils, follow the engine builder's specifications but permit the fuel supplier as much latitude within them as possible. 9.4 is gas fuel. The express purpose of the gas diesel and dual fuel engine is to take advantage of availability of low-cost gas fuel. Any gas suitable for fuel for gas engines can be used, but natural gas and sewage gas are most common. The cost of pilot fuel oil is of lesser importance, and it is wise to use a good grade of fuel oil. Section 10. Gaseous fuels. Characteristics and properties of fuel gases. Advantages. Gaseous fuels commonly used in industry, whether distributed by public utilities or produced in isolated plants, are composed of one or more simple gases in varying proportions. They can be burned in furnaces or other appliances under conditions in which the supply can be varied almost instantaneously between wide limits by the manual or automatic manipulation of a valve. Gas analysis. In ordinary methods of gas analysis, the gas passes through a series of absorbents, each of which removes a district's components or group of components. The remainder of the gas is subjected to combustion with oxygen or air. Measurements are made on a volume basis, and the results are expressed in percentages. Heating value. The total heating value or gross heating value or higher heating value or HHV of a gas is the number of BTU produced by combustion at constant pressure of 0.0283 cubic meter of gas measured at 15.5 degrees centigrade and 762 millimeter mercury with air of the same pressure at and temperature as the gas. Section 11. Diesel lubricating oils. Classification. Crude oils are frequently described as paraffinic, naphthenic, or mixed base according to the physical characteristic of the crude. Many sub-classifications of finished oils can be made based on type of base stock, refining methods, and subsequent treatment, but these classifications do not describe the value of a lubricating oil in a diesel engine. 11.2 types. The Society of Automotive Engineers and the American Petroleum Institute recognize three types of lubricating oil. Regular type, suitable for moderate operating conditions. Number two, yung premium type, having oxidation stability and bearing corrosion preventive properties, making it generally suitable for more severe service than regular duty type. Heavy duty type has oxidation stability, being corrosion preventive properties, and detergent dispersant characteristics for use under heavy duty service conditions, carry carbon particles in suspensions, and tend to eliminate deposits in the engine. 11.3 is the characteristics. Specifications for lubricating oil do not usually mention any physical characteristics except viscosity, but such characteristics should be considered. Viscosity must be high enough to provide an oil film under the load and temperature conditions prevailing between the sliding surfaces in the engine, and still flow freely through a passages and spread over sliding surfaces under the prevailing speed and clearance conditions. 11.4 is the SAE grades. Society of Automotive Engineers or SAE viscosity numbers classify motor oils and grade lubricants solely according to viscosity limits. SAE numbers are a means of coordinating and standardizing the products of oil companies and the recommendations by the oil companies. The system of SAE motor classification is a system based entirely on viscosity and is totally unrelated the other qualities of a lubricating oil. The viscosity of lubricating oil usually expressed according to grades established by SAE given in the following table. So yan, SAE viscosity number. Then isa yung viscosity range at 130 degree Fahrenheit, minimum maximum. Then yung isa kabila is at 210 degree Fahrenheit. yung minimum and maximum. So, yung viscosity number niya is 10. Pag minimum siya ng 130, 90 siya. Yan, ang dami niya. Hindi na siya explain. Yan, viscosity index indicates the relative change in viscosity of an oil for a given temperature change. Pour point is the lowest temperature at which oil will flow its own accord. It is not the only factor influencing the ease of starting a cold engine, especially after it is exposed for some time to cold water. Then ayan, flash point again. In lubricating oils, the flash point is valuable for purposes of identification. The flash point of an oil is rough indication of its tendency to vaporize at high temperatures and therefore of oil consumption, especially in internal combustion engines. Yan. Color. The color of oil is no indication of its lubricating qualities, except in so far as contamination may be evident. Sometimes the degree of deterioration can be estimated by comparing its color to that of unused oils. Yan. Yan yung kulay. New oil charge, oxidation has begun. Time to change the oil. Then, ayan na. Nangitim na. Engine operation. Normal operation of a diesel engine subjects the lubricating oil to high pressures and temperatures. The result is oxidation and the tendency towards production of gums, resins, and acids. The products of oil deterioration are an almost infinite series of compounds, differing according to the oil used and the operating conditions. Yan, alam na natin yan. Section 12, Units of Heat Measurement. Several units for measuring the quantity of a heat in a body are in use. The relations between them are given in table 15.13.1. The British Thermal Unit or BTU, generally used in engineering work in the United States and Britain, is 1 over 180 of the heat required to raise the temperature of 1 pound of water from 32 to 212 degree Fahrenheit. Originally, it was defined as the quantity of heat required to raise 1 pound of water from 62 to 63 degree Fahrenheit. But the former definition is now generally accepted. The kilogram calorie or large calorie is the heat required to raise the temperature of 1 kilogram of water from 14.5 to 15.5 degrees centigrade, or 1 over 100 of the heat required to raise 1 kilogram of water from 0 to 100 degrees centigrade. The gram calorie, small calorie, or 15 degree calorie, generally used in scientific work, is the heat required to raise 1 gram of water from 14.5 to 15.5 degrees centigrade. So, ayan yung table niya. Relation of the various units of heat. Yan, conversion lang. Mechanical equivalent of heat. Yan. Ang dami. Conversion lang naman. And thank you.